Uh, so again, I am welcoming you all to this online class organized by Regional Center Bhubaneswar. Um, these classes are the theoretical classes of your postgraduate diploma in analytical chemistry program, and mm, in the last 3 days, we have discussed your second paper, MCH-002 paper, which include your separation techniques followed by your solvent extraction. And yesterday we have gone through the chromatographic method with its basic theoretical part, and also we have discussed the liquid chromatography LC yesterday. So today we have the like your solids chromatography, or the where the stationary phase is a solid. We have to we will discuss this part today, and today we have unit 6 of your paper, that is related to your planar chromatography. So I am sharing my screen with you. Just wait. I think my screen is very much shared now, and we have this unit today, that is unit 6, planar chromatography. So in this part we will discuss the stationary phase as a solid. That means this is your liquid solid chromatography, where liquid is your mobile phase, and a solid substance acts as your stationary phase, which is immersed in a selected elute or solvent, and we will have our components with distinct color on a chromatogram. So whether my screen is very much visible to all.
Yes, you are
Yeah,
visible.
Anyone please confirm by putting a message in the chat box. Is it clearly visible? Okay. Sorry, wait. Something went wrong. Okay. So the planar chromatography, planar means it is just a plane, and this plane belongs to the stationary phase, the solid. That means if I take a paper as the stationary phase, it is known as the paper chromatography. So as we know, paper is a two-dimensional surface or plane on which we will have our chromatography experiment. So paper is the stationary phase. Similarly, in this category, we also have another type of chromatography, that is thin layer chromatography, where we will have the stationary phase in a layering like structure, which is developed by selection of some adsorbents, and by preparing a slurry, we will have our stationary phase in the TLC, thin layer chromatography. So in this unit, we will discuss about the paper chromatography, followed by your thin layer chromatography. So depending upon the type of adsorbent, that is the type of stationary phase, we will have two types of TLC, that is the ordinary TLC or general TLC, thin layer chromatography. And if it is a very fine powder adsorbent, or the stationary phase, which is used to make the your layering, then this will be known as your HPTLC, that is high performance thin layer chromatography. Okay. So these are the things, overall things in your unit 6, and this is our PPT for today's part, that is the paper chromatography. So before going to this slide, let's have some introduction or related to your paper chromatography. This paper chromatography belongs to your planar chromatography, and in planar chromatography we have generally three types of chromatography are there, that is your PC, that is paper chromatography, thin layer chromatography, and electrochromatography, that is EC. So each of these technique make use of stationary phase in the form of a sheet or flat surface of a paper or any other material such as metal, glass, plastic plate coated with suitable adsorbent with the help of binder. So once upon a time the planar chromatography included two-dimensional chromatography like our paper, though it has now come to signify the coupling of two chromatographic techniques with different mechanism of separation. It is called planar because the stationary support consists of the plane surface of the paper or smooth glass plate. So as we used this plane surface to have our chromatography experiment, so this is belongs to your planar chromatography category. um, then it also include electrophoresis or electrochromatography, which we will discuss at the end of this paper. That it is in your unit 12, electrophoresis, where the movement of mobile phase is assisted by electrical potential. However, it will not be discussed here. The paper chromatography and thin layer chromatography have the advantage of being simple, fast, and inexpensive. These methods are very simple. Anyone can do this by knowing the principle, general principle, and these are also inexpensive, and also it will take few minutes or time for this experiment. These are very fast. These have been widely used for the qualitative identification. This is very important. So this paper chromatography or thin layer chromatography is widely used for qualitative identification, means to determine the determination of the type of component present, not the amount of component. It is the type of component we may able to know through this experiment. um, it is not used so commonly. Paper chromatography used nowadays not commonly used, and TLC is now very widely used in different organic synthesis lab, drug industry, clinical industry, pharmaceutical industry, and biochemical investigation in biochemical processes. In both the cases, sample is spotted with a micropipette on a paper or plate. So the sample is put here using a micropipette or a capillary tube, and that is drop by drop. One drop is placed here, then we have to dry it through hair dryer or at ordinary temperature. Then after drying, then we have to put the another drop here, the same mixture, another drop. Then we have to put 3 to 4 drops here and drying well. After the drying, we have to run the chromatogram by putting it in a suitable solvent or eluent. Then after this, just in this slide we have this paper chromatography, where this paper is the stationary phase, and at the bottom we will put one line here. Then we will put our sample with a micro pipette or a capillary tube. So we have to put the sample 3 to 4 times, that is 3 to 4 drops, uh, and after every drop we have to dry it through hair dryer or in a normal atmosphere or normal environment. Then in here, what are the two phases? The paper is the stationary phase, and it will put in a suitable solvent. That will be the mobile phase. So the stationary phase is a water molecule bound to one cellulose matrix. So this paper is consisting of cellulose in which the water molecules are bound, and the mobile phase is the suitable solvent. That is the here it is for example it is written butanol with acetic acid. So solutes are separated according to the solubility in mobile phase or their attraction to the stationary phase. So the attraction or the interaction between the component with the stationary phase, that is depend on the polarity. That is higher. If the component is having higher polarity, then it will be at the bottom, but at the lower end. And if it has lesser polarity, then it will be at upper end. Okay. Then we will have, sorry, then we will have paper chromatography which of two types, that is ascending and descending. So before going to this part, let's have our PDF. Okay, what are the objective in this part or in this unit? The objectives are uh, by going through this unit, we will explain the meaning of planar chromatography, the principle of paper chromatography, describe the principle of paper chromatography, give the meaning of RF, that is a retardation or a retention factor, and what are the factors affecting it. Discuss the type of paper used as support and the types of solvent mixture used in paper chromatography. Describe how to run and develop paper chromatography. Explain the methodology and separation of inorganic and organic mixture. Give the potential application of paper chromatography. Then we will move to TLC. What is the principle? What is the support and type of mobile phase? Explain how to run this TLC. Discuss the advantages of two-dimensional paper and TLC. Applying plate concept to TLC. Describe on the quantitative aspect of PC and TLC. Then at the end it will be comparison. So paper chromatography, the principle is very much easy, and as written here, the this paper chromatography during the 19th century, Ranj, Keben, and Gopalsweder separated colored dye and other chemical on paper or cloth, which is considered as old cousin of paper chromatography. In 1944, Konsen and Goran, two workers from AJP Martin, of AJP Martin, the Nobel laureate, first reported the foundation of paper chromatography by separating the mixture of amino acids. The technique is based on the movement of solvent phase in upward or downward direction. So this is upward or downward. That means this is of, sorry, this is of two types. If it is upward, this is ascending type. If it is downward, this is descending type. We will have the um, description later part, in the later part. Then another type of paper chromatography was there, that is known as circular paper chromatography, where the paper is cut like a circle, and in by using this circular paper we have the chromatogram. So what is the principle? The principle is very much easy, that uh, the technique of paper chromatography consists of sheet of cellulose filter paper which serves as a stationary phase or separation medium. A small amount a small amount of solute is placed in the small near area of the strip, like this. We have to put one small area for our sample, and that is area near the end of strip, like this, end of the strip. A solvent is allowed to move from the end of the paper by capillary action, and after equilibration for some fixed period, the solute migrates from the initial point of application. The components of the mixture are separated completely or partially with distinct colored zone, like this. with paper chromatography. Here the samples are taken at the bottom and it is dipped in a suitable solvent. Here there is organic solvent, and this paper is consist of a cellulose. Water molecules are bound to it. Okay, cellulose paper. And after putting this paper in this solvent, there will be migration or a movement of different components on the basis of their interaction with the solid phase. Okay, then in the principal part we will have a distinct color. Then these colors are seen under ultraviolet light or in an iodine vapor atmosphere. So if it is not seen through naked eye, then I will use ultraviolet or fluorescence light or iodine vapor environment. The paper chromatography was considered as simply a form of liquid-liquid partition, or it is your solid-liquid chromatography. The hydrophilic fiber of the paper can hold water in humid atmosphere such that a large percentage of water may be held in filter paper, as the water molecules are already bound to the cellulose paper. Thus, the paper was considered as the analog of a column containing a stationary aqueous phase. The solute molecule gets partitioned between this water and the mobile immiscible organic solvent, and in the latter part we will have the movement of the components depending upon their interaction with the stationary phase. Okay, then a factor is very much essential or very much an important factor known as RF value, that is known as the retardation factor or retention factor. It is abbreviated as, just see this one. Yes, this one. So this is the known as the RF value, means it's retention factor or retardation factor. So this RF value or depending upon this RF value, the migration or the movement of the components occurs. So what is the formula of this? Now RF value, it is a characteristic parameter called retardation factor, and it is abbreviated as RF. It represents the position of an ion or a substance with respect to solvent phase. RF of a solute is defined as the ratio of the rate of movement of the solute to the rate of the movement of the solvent. That means if the movement of the solvent is up to this and movement of the solute is, this is the solute, this is the red spot, this is the solute part. So what will be the RF or retention factor value? It will be movement of the solute, that is Y, divided by movement of the solvent, that is X. So Y by X will be your retention factor. That means what are the conclusions made from RF value? The conclusions may be when the RF value, when the RF value is close to 1, if the RF value is close to 1, that means the component is a less polar component and it will travel more distance. Okay, as the maximum value of RF will be 1, because Y by X, the maximum value will be 1. If is the maximum value 1 and the RF value of the component is close to 1, that means the component is having lesser polarity. And if it is lesser polarity, that means the distance covered is maximum. Okay, then similarly, if the RF value is close to 0, that means this is the 0 line where the RF value is 0. And if it is close to 0, that means the component is a polar component, and it will cover a minimum distance depending upon its polarity. that the more is the polarity, more is the interaction or attachment to the solute stationary phase, and lesser will be the distance covered by the component. So that's why RF will be lesser when the distance covered is very small, and RF will be higher value if the distance covered is maximum. And we will have to remember one thing that the maximum value of RF will be maximum 1.0. It cannot exceed 1.0. That's why. Okay. Then this is the distance covered by the solute divided by distance covered by the solvent. That means it is the distance covered by the stationary phase divided by distance covered by the mobile phase. The solvent is the mobile phase, and the distance covered by the component means distance covered by the solute, that is the stationary phase. So that way this is also ds by dm. So it is the RF value is close to 0, that means it has more attraction to stationary phase. RF value is close to 1, that means the solute has more affinity for mobile phase and travels further. The final chromatogram can be compared with the other known mixture chromatogram to identify the sample mixtures. Okay, and I also have one, just wait. RF value, I have one PPT also there for your RF value. Just wait. RF. I think there it is. Yes. Just see this one. We will also discuss in the DLC part. And this is the RF. Just imagine this is the cellulose paper or the in paper chromatography, and these are the samples we have taken. That is A, B, U, C, D, and the distance traveled by A is this one, B is this one, U is this one, C and D. Okay, so distance, the total distance traveled by the solute is from this point to this point. Okay, let us the total distance covered is 5 centimeter. So this will be fixed for every component for RF calculation. So the distance solvent migrated is 5 centimeter. Okay, so let's have our first sample, that is A. The distance covered by A is 2 centimeter. So what is the RF value? RF value will be distance covered by the sample solute, that is 2.0 centimeter, divided by total distance traveled by the solvent, that is 5.0. So RF of A will be 2.0 by 5.0, it will be 0.40 RF value. Similarly for B, the distance travel is 3.0 and distance travel with the solvent is 5. That means it is 3.0 by 5.0, that is equal to 0.60. Similarly for your C, the distance travel is 0.8 centimeter. It is 0.8. This is 0.8 divided by 5, 0.16. Then D, it is 4.0. So for D, it is 4.0, 0.80. For U, we have two spots. That is, first one is 0.8 and second one will be 3.0. So 3.0 by 5, 0.6, 0.8 by 5, 0.16. So by knowing these RF values, we may conclude what are the type of molecule, the type of a type of sample A, B, U, and C, D are, and what type of interactions are supposed to be happen between these samples and the stationary phase. So between all these, 0.60 of RFB and 0.60 of RFU1. So RFU1 means this one. RFU1, that means these have higher value of RF. Sorry, higher value of RF is D, the sample D. The sample D having RF value 0.80, that is very much close to 1. So if it is close to 1, that means it is the most non-polar compound of this chromatography experiment. This is maximum non-polar, and the minimum will be C and U. Okay, so this is very much close to 0, that is 0.16 and 0.16 for C. So by knowing the value of RF, we will conclude the type of substance, the type of substance or the type of compound we will have in our chromatography experiment. Okay, then let's have our PDF here. And these are the principles. Just see this one. This is the cellulose or the stationary phase of the paper chromatography chromatography experiment, and the RF will be the distance traveled by this component, that is X, divided by distance traveled by the solvent, that is Y. So this is X by Y. So what are the factors we may consider? That is presence of other ion or impurity. If impurities are present, then like your chloride or chloride with nitrate, these are the common other ions generally present in the solvent or the chromatogram. Acidity of the original solution, this also have related to your change in pH, so we have to maintain the acidity. So development time, that is the running time, therefore optimum time may be determined. Presence of other cation anion as impurity, then ambient temperature. So these are the factor on which the RF value depends. Since RF value depend on the distribution of the complex species of cation with different organic solvents, um, so solvents should be carefully chosen. The technique for PC is primarily used for qualitative identification, though it could not be used for quantitative determination but with poor precision. So this is generally used for your qualitative identification, means to know what is the component and what amount it is present or what quantity it is present, it cannot be determined through this paper chromatography experiment. It could be a best considered semi quantitative technique. So these are the points, and then we will discuss the stationary support, that is the stationary phase. What are the substance generally used to prepare the stationary phase in a paper chromatography? um, Generally, the filter papers made up of your cellulose, highly purified cellulose filter paper, named as your Whatman paper, paper 1 or 2 or 31 or 3, 31 and 3 mm, or acetyl paper having hydrophilic affinity for water. These are generally used uh, to have the stationary phase in paper chromatography. The solvent penetrates the filter paper or this fiber, that is cellulose, and causes swelling of paper changing its dimension. Polymeric cellulose structure contains several thousand anhydroglucose units linked through oxygen bonds. So it should not have impurities like calcium, magnesium, iron, copper, etc. to avoid interference. And also sometimes the paper is coated with the chelating agents like the ring forming ligands or groups, like your 8-hydroxyquinoline dimethyl These are also the coating materials for your chelation. The paper is impregnated, either neat or dissolved in a volatile solvent. So the papers of following properties: weak ion exchange property, adsorptive property, water holding property, okay, yeah, yeah, decay, and mild reducing agent. So these are the properties that the stationery or the paper should have. The quality of paper and its porosity, this is very much important. The quality and the porosity plays an important role in PC, and it determines the rate of movement of the solvent. So the quality, that the paper must be high quality cellulose content filter paper, and the porosity, if the porosity is very, porosity is small, then the movement will be lesser, or movement is very slow, and vice versa. The thick papers with increased sample capacity may be used for preparative study. The most suitable cardboards are these are the examples of your papers used in PC. Generally, a paper strip of 4 into 30 centimeter for one dimensional and 30 into 34 square sheet for two dimensional purpose. This type of papers are used for one dimensional, um, very small breadth and 30 centimeter your length. And if it is two dimensional means it will be immersed in the solvent in two directions, that is horizontally and as well as in vertically. Okay, so this is the stationary phase preparation. Then we will have the solvent system. What are the solvent system we have to select for this paper chromatography experiment? The solvent the solvent should not react chemically with the component of the sample mixture. So these are the properties the solvent must have or should have, that it should not react with chemically react with the component of the sample mixture. The composition of solvent mixture should not change with time. It means that none of its components should be volatile. So a volatile solvent will not be used, and the composition must not be changed. The solvent should not interfere with the detection of spot. That while we are going for the detection of the spot, if the solvent interferes, there we may or may not have the clear vision of the spot for its detection. The distribution ratio should be independent of solute concentration. Distribution ratio that is related to a retention factor, right, or retardation factor, that is RF. The minimum difference between RF value of any two components should be 0.05 or zero point 0.1, so that they may be separated easily. That the minimum distance or difference between the RF must be 0.05 or zero point 0.1. Then some of the solvent commonly employed are N-butanol in 3 molar hydrochloric acid, that is acetyl acetone saturated, then acetone containing 5% volume by volume, then glacial acetic acid, methanol. So these are the solvents generally used. Methyl acetate, pyridine containing 10% volume by volume water, dried N-butanol containing 40% volume by volume dry methanol, etc. So how we can develop the chromatogram? So just see this one. this is let us this is the cellulose filter paper or cellulose paper we use for the stationary phase, and this is of the dimension this is 30 centimeter into 30 centimeter, that is it is a perfect square. Let us then we have to put one line just above the lower part of the paper. Just above the lower part of the paper, we have to put one line, and with the help of a micropipette or capillary tube, this is the capillary tube micropipette, we have to put our sample with a certain gap. That is, if A is here, then at a distance of at a considerable distance, we have to put B and subsequently C and D. And what is the procedure for putting this sample at this origin line? Now we have to put the same sample A 3 to 4 times, drop by drop. Then first we will use this capillary to put one drop. Then I have to dry it with the hair dryer, or which will blow hot air. So with the help of hair dryer, I will dry it. Then after drying, I have to put again one drop. Then again the drying is continued. Then third and maximum it will be 3 to 4 times. So after putting these samples and after drying all the samples, we have to then put these in a chromatogram. Chromatogram is the chamber. It is just made up of a glass chamber, with one lead is there or cover is there at the upper part. Then we have to put that paper at the in the chromatogram chamber, and in which the suitable solvent is there. After putting this, the solvent will go up by the capillary action, and when it is go up, it will simultaneously react with these samples, and um, with respect to the interaction or the polarity of these components, the different components will have different colored spots in this chromatogram paper or in this stationary phase. Okay, so this is known as the ascending paper chromatography, because here what happened, the movement of these components from bottom to top or from lower part to upper part. So this is the ascending, that is lower to higher. This will be ascending. So in the descending, what happened? In the descending paper chromatography, there is a trough for solvent. Trough means this is just like a box containing the solvent, and this is solvent. There is a glass rod is attached here, and to this glass rod, our cellulose paper, will be hanged from the top to bottom, and before that we will have our all the samples like this. So if I put this sample in this chromatogram chamber, what happen? There will be there will be there will be movement of the components from top to bottom. If it is top to bottom, that means this is a descending paper chromatography, and this one is the ascending paper chromatography, where there is movement from bottom to top, and here from top to bottom. So this is the descending and this is the ascending part. Okay, so just remember these things. There are two types of paper chromatography: ascending and descending. So just see here, this is anti-siphon rod which contain the chromatography paper, that is cellulose paper, where fixed tank sides on which trough can rest. So this is just a stand-like structure where this trough is set here. Glass anchor rod. These are the glass anchor rods. Then anti-siphon rod here. So just try to remember this diagram, which may be required for your theoretical examination. So this is a top down approach and down top approach. Okay, if it is top down, that means it is descending, and if it is down top, this will be ascending type. Then we have uh, the development time will depend on the complexity of the mixture of solutes being separated, solvent system, and the quality of the paper and the ambient temperature. The diffusion of the solvent and the resulting separation into spot is termed as development of the chromatogram. It is essential that paper should be equilibrated with the solvent vapor in the chamber. For a good resolution, RF value must be 0.04 to 0.8. For a good resolution or good chromatography experiment, the RF value range must be 0.4 to 0.8. So these are the sources of error, that is lateral diffusion, variation in structure of paper become important, especially for the concentrated solutes, variation in geometry, etc. So next we are the detection methods. How we will detect that what type of component is there after the paper chromatography experiment is done. So after the paper chromatography experiment, how we can predict or determine what type of compound is there in our sample. So if the coloring reagent, the reaction with coloring reagent as a dimethyl glyoxime is used for your nickel and hydrogen sulfide gas for any group 2 elements. That means after the spots are separated, we have to react this paper with dimethyl glyoxime solution. If it is becomes a red color, that means nickel is present. These are just examples. Okay, if we pre-predict that nickel might be present in my sample, then we have to put this paper in the dimethyl glyoxime solution. Then if group 2 elements are present, group 2 means it is that, let us barium, beryllium, magnesium, this type of elements are present, we have to react with the hydrogen sulfide gas from your Gibbs apparatus. Then fluorescent producing reagent, this is the UV light, inert visible color, radioactivity measurement from radio pressure, electrical methods, the potentiometry, conductance measurement, etc. etc. So these are the reagents which are frequently used to determine the what type of component we have in the mixture. The reagent employed including diphenyl thiocarbazole, rubianic acid, diphenyl, thiocarbazide. These are the reagents also used for the early detection of the components. And a very important factor is the RF value. This RF value scientifically or experimentally prove that what type of component we have in our mixture. For example, this is an example that in a paper chromatography, we have to separate silver, lead, and mercury. Let us the solvent rise to 18.4. That means it is the total distance traveled by the solvent. That is the at the denominator 18.4, and the spots are seen at 15.8, 12.1, 5.9 distances. So what are the RF values? The RF values will be 15.8 by 18.4, 12.1 by 18.4, 5.9 by 18.4. So 0.86, 0.66, and 0.32. And in the latter part, it is also written that a spot is correspond to RF value 0.65 was observed. What is the possible pollutant metal in the emission gas? So 0.65 means it is just close to your 0.66. So if it is 0.66, then the pollutant is your lead, Pb plus. Okay, so this type of problem you may face, that the RF value is you have to calculate the RF value by the distance traveled by the mobile phase and the stationary phase. So the solvent is 18.4. This is a mobile phase, and the component or the pollutants travel the distance is 15.8, 12.1, 5.9. Yes, you have to divide these things individually, and by comparing the RF value with the individual RF value of the components, then you are able to conclude what type of pollutant the gas has. So what are the applications? Application is identification of trace metal in oats, checking purity of pharmaceutical and fermentation, refining of fruits and fermentation products, detection of adulterant and contaminants in food, etc. So this is an example of one dimensional. So this is an example of two dimensional. Okay, so this is the example of one dimensional. This one. This is one dimensional, 4 centimeter into 30 centimeter dimension. Then in the two dimensional, we have a paper just like a square dimension, that is 30 centimeter into 30 centimeter. Yes, that is 30 centimeter and 30 centimeter of dimension, and we have to put this paper. We have to put this paper first horizontally and followed by vertically. Just see this diagram. In this diagram, a square paper 13 to 30 centimeter is taken and a sample is spotted at one corner of the sheet. That means it is spotted at one corner of the sheet here. Then chromatogram is developed using one solvent where solute is migrates parallel to one edge of the paper. Next time the paper is turned at 90 degree and the developed is in a second solvent system which carries the solute into the unused portion of the paper. A typical chromatograph just here it is given. Then what happened here? This is the sample. This plus is the sample, and it is first the solvent used is butanol acetic acid. If I put this sample and this corner of this paper, then we have the amino acid, that is cysteine, aspirinic acid, glutamic acid, serine. This type of components are separated. This is known as the horizontally. And at the same time, after the horizontal experiment, I also put this same corner vertically. Then vertically what happened? There the samples like arginine, lysine, histidine, alanine, proline, tyrine, valine, this type of amino acids got separated. That means we have two types of separation here. That is one in butanol acetic acid in horizontal direction, and the second one is phenol, cresol or water. This is in vertical. So this is two-dimensional paper chromatography, where two dimensions are used, that is a two axial directions are used. This is one axis and this is the other axis. And in two axes, we are used two different type of solvents, one in horizontal direction and one in vertical direction. So the C in horizontal direction, the samples or the spots are in horizontal direction like this, but in vertical the samples or spots are just like this, just above. So these are the two-dimensional paper chromatography. Then we have a separation of identification of like manganese, nickel, cobalt, nickel, cobalt and zinc, and these are the RF values. 0.09, this is performed in your Wattman number 1 filter paper, and the solvent used is acetone, water, hydrochloric acid system, and these are the examples. Okay, separation of mixture of pesticides. So if we have aldrin, endrin, linden, DDT, BHC, benzene hexachloride, dichlorodiamine, trichloroethane, like DDT, and this type of pesticides also we will separate each component from the mixture by using a Wattman filter 1 filter paper, mineral oil in diethyl ether 5% volume by volume, and 75% in aqueous. These are the retention factors, that is for your 0.37 for aldrin, 0.41 for heptachlor, 0.6 for your DDT, and etc. Then separation of different anions of sulfur. So these are the different anions, that is sulfide ion, this is sulfate, no, this is not sulfate, this is this is sulfide, this is sulfite, this is sulfate, this is the disulfate, and this is thiosulfate. Using radio tracer S35. This is one radioisotope of sulfur. Sulfur has three isotopes, that is 34, 35, 36. And this is the 35 isotope, and here using this isotope we will distinguish what type of sulfur ions are present in our mixture. Here also Wattman filter paper 1 is used, and the solvent is dioxane in butyl alcohol in 1 is to 1 is to 1. Also ammonia is there, and the RF values of these different ions are here: 0.12, 0.43, etc. Then we have uh, auto radiography using radio tracers. That auto radiography is there. That means radioactive elements are used where a radio tracer radio labeled solute sample is used after development of the chromatogram. It is kept in contact with the photographic film of the same size. After some time, when the film is developed, then dark spots are observed in place of spots corresponding to movement of solute. So this is known as your radiography. That when the film is developed, the dark spots are automatically generated as these are the radio type samples. So, so this is known as radiography. The examples are in chlorophyll, C14P32S3, that is tritium. If this type of isotopes are used, then we will have the auto radiography technique. Then just just an example of this autoradiography. We have one leaf here, and we have to put this leaf in a CO2 having C14 isotope. CO2 containing C14 isotope. Carbon dioxide environment. If I put leaf irradiated by light in C14O2 atmosphere, then after prolonged photo-induced biological reaction will be occur, then we will cross this paper with pestle and mortar. Then after grinding these things, we will take the sample as the sample in at the bottom, that is the chromatography paper. In the paper chromatography, then we will have the solvent mixture with internal water here, and this is the sample, and these are the different type of components, that is P, Q and R, and this is the maximum height of the solvent rise. So what are the retention factor? Retention factor will be A by B. Okay, so this is all about our paper chromatography experiment, and the second part is this in this unit is your thin layer chromatography. So I think my speaker is not working today. If you have doubt, please post your question at in the chat box. I will reply. If anyone. Paper chromatography, just like your one cellulose paper is used, then suitable solvent, and our sample is put using micropipette or capillary, and it is put in the chromatogram chamber, and depending upon the dipolar or polarity or the interaction with the stationary phase, the components got separated, showing their different coloring spots on the cellulose paper. Okay, let's move. Then we have the thin layer chromatography. Just we will have this PPT first, then we will go to the PDF of our IGNO. So this is thin layer chromatography. In short, it is TLC. These are the contents of this presentation. Introduction followed by general application, general principle or theory. Then what are the techniques and the applications of TLC. So thin layer chromatography is an important technique used for identification and separation of mixture of chemical compound in its individual components. Okay, so this is a very popular and widely used technique as compared to paper chromatography. So TLC is a form of liquid chromatography consisting of mobile phase liquid and solid phase solid stationary phase. So differences in the interaction between the solute and stationary and mobile phase enable separation. So everything depends on the interaction, and interaction depends upon the polarity. If the solute polarity is more, then the spot will be at the lower part. If the polarity is higher, sorry, the polarity is lesser, the spot will highlighted at the upper end of the paper. So the TLC is different from paper chromatography, where a flat surface of glass, metal, or plastic coated with adsorbent such as silica gel, alumina, or any other material is used. So here the stationary phase is coated with adsorbents like silica gel, alumina, etc. And this technique was discovered by Scraber. It is written in your PDF. Okay, Scraber in 1938. It is faster, more sensitive, and it has better resolution than paper chromatography. TLC is used to develop optimal conditions for separation by liquid chromatography. The technique has become a workhorse for the drug industry and other purification products. It has also found widespread use in clinical, industrial, environmental labs. So, what is the stationary phase? As we highlighted here, that there is a stationary phase which is the adsorbent, and there is mobile phase which is the solvent. So, the stationary phase is just see this one. This is the stationary phases. So the stationary phase used in TLC is the adsorbent phenomenon or ion exchange molecular sieve, and it serves as the support for a liquid film. It consists of a finely divided powder of particle size 5 to 50 micrometer. A variety of stationary supports are available for coating for smooth surface of glass, metal, or plastic. So silica gel with a silica gel G with 60 to 120 mesh remain the most frequently used coating material. The silica gel is frequently used, and how the stationary phase is prepared. A slurry is first a slurry is prepared, and that's just see this one. Yes, there this part. What happened? This is the applicator containing the slurry. So this slurry is made up of your silica gel 60 to 120 mesh. It contains hydroxyl group on the surface which form hydrogen bond with polar molecules. The adsorbed water prevent other molecules. Hence, the gel is activated by heating to remove the adsorbed water. So generally, what happen? Um, an aqueous slurry of the powder is prepared by mixing adsorbent, that is silica gel, with a binder such as calcium sulfate, that is a plaster of Paris. So we have to prepare one slurry with silica gel or alumina with our plaster of Paris, that is calcium sulfate, and polyvinyl alcohol to help it adhere to the backing material. So it is just add to stick or adhere the backing material. It is uniformly distributed by using this applicator. So this is the plate, that is the thin layer chromatography plate, and where this tray with coated plates, and with the application of this applicator containing the slurry, this will be distribute the slurry uniformly through this plate. So we will, after some time, we will have the a film like structure or a plate like structure, which is very much used for this thin layer chromatography experiment. The thickness of the layer is 0.1 to 0.3 millimeter. Okay, and the solvent is evaporated off and the adsorbent are activated by placing in an oven at 110 degrees centigrade for few hours. Pre-coated ready to use plates and sheets are also commercially available. So these TLC plates are also commercially available. If we want to prepare one TLC plate, um, then we have to do these things. That is, we have to prepare the slurry, with plaster of Paris, polyvinyl alcohol, and the adsorbent like silica gel, and putting this slurry in this applicator. And this is the tray of this TLC containing coated plates, and this will be uniformly distributed with the help of this applicator. We will have different plates of the TLC which we may use in our TLC experiment. So this is the stationary phase. This is a TLC plate. Okay. Then just read out this one. The surface of the TLC plate should not be touched. So it should not be touched with with your finger or any other apparatus. It should not be touched because the planarity will be deformed, because these two, that is vapor chromatography and thin layer chromatography, both belongs to your planar chromatography. So if it is touched, then the planarity will be deformed. The plates should be handled carefully by holding the edges so as to avoid any contamination due to sweat. So it is very much a careful procedure to prepare the stationary phase, that your sweat must not be contact with the plate, or if there will be no contamination due to your sweat. The plate should be cleaned thoroughly so as to remove any extraneous material that might contaminate the adsorbent. So this is the precautionary things we have to maintain. And this is the preparation of your stationary phase, followed by mobile phase. Mobile phase is just your solvent, and use of the choice of mobile phase is largely empirical, and it is just a heat and trial method. And a mixture of organic solvent and water with the addition of acid base or complexing agent to optimize the solubility of the component of a mixture can be used. And what are the criteria? The developing solvent must be of the highest purity. This is very important. The solvent must have highest purity, because even trace amount of impurity may yield irreproducible results. Good separation of polar or ionic solute can be achieved with a mixture of water and N-butanol. The criteria used for the selection of developing solvents are the same as for column chromatography. So the criteria are more or less same. The eluting power of solvent increase in the order of their polarity. Very important line. That is the eluting power, or the movement or the migration of the component in the solvent depend upon the its polarity. So from uh, polarity of the solvent, from hexane to acetone to alcohol to water. So hexane the least polar, water the highest polar solvent. An heliotropic series given in 6.1 table can be used for the selection of best solvent or the solvent mixture for a sample. So let's have the 6.1 table. This is a 6.1 table. This is the solvent strength, where the N-pentane has the solvent strength of 0.0, and followed by your ethylene glycol having 1.1 solvent strength. Okay, and the last point, if the stationary phase is hydrophobic, that is uh, it is hydrophobic means it hates water interaction. Mixture of benzene, cyclohexane, and chloroform in different ratio provides satisfactory mobile phase. So these are the criteria for selection of your mobile phase. Then apparatus and requirements. The plate size 2.5 into 10 centimeter, or 2.5 15, 2.5 20, 5 into 20, 10 into 20, 20 into 20, depends on your size of the sample or number of samples. You will choose the size of the plates. Okay, then two types of plates are available. They are conventional or general and high performance. So in conventional, the there will be thicker layer of about 0.25 millimeter of particle size, uh, thicker layer about 0.25 mm, with particle size of less than 20 micrometer. This is for your conventional or ordinary TLC plate. Okay, so but for your high performance TLC, that is HPTLC, the thickness of the plate is 0.1 millimeter and particle size is less than 5 micrometer. Okay, so when the thickness is reduces and the particle size reduces, what happened? The pore size also reduced. So when the pore size reduced, there will be high performance of the plate and the separation will be more effective than conventional TLC. So just remember, two types of plates are there: conventional plate and high performance plates. In conventional, the thickness is 0.25 millimeter and it's with particle size of less than 20 micrometer. But in high performance TLC, the plates of thickness 0.1 millimeter with particle size of less than 5 micrometer. Okay, so as the name implies, high performance plate provide fast and sharp separation. In terms of plate theory, the conventional TLC will be about 2000 plates in 12 centimeter. 2000 plates in 12 centimeter means there will be small labels are created. So in 12 centimeter of length, 2000 plates are created in conventional TLC. But in HPTLC, high performance TLC, we have 4000 plates in 3 centimeter area. So it is almost 10 times. So that's why high performance TLC is much more effective, or it has high performance than conventional TLC. This is the conventional. Okay, so then this is the ascending one from lower to bottom, and this is the horizontal one where the sample is taken here. There is developer, there is a cover here, and this is the old method, this is the new method. Okay, the sample application in TLC is most critical aspect, and particularly so in quantitative measurement. Usually the sample is dissolved in a suitable solvent with a concentration of less than 0.1%, just 6.2, the figure 6.2. In case of dilute solution, 3 to 5 drops are applied. This is a general procedure that you have to put minimum 3 and maximum 5 drops of the same sample in one spot with the help of micropipette or a capillary. The spotting may be done with a capillary tube or by use of hypodermic syringe. You may also use hypodermic syringe, and generally we are using the capillary, the best and easy handled apparatus. However, mechanical dispenser with increased precision accuracy may be commercially available. And this is a horizontal thin layer chromatography, and this will be the ascending chromatography. The plate is immersed in developing solvent, avoiding the direct contact. The developing solvent travels up the plate, and after passing to the point of sample application, it dissolves the sample and carries it up the plate, that is in the ascending part. Okay, and this is the detection method. How to detect what type of components you have. The detection of spot in TLC is very much easier than paper chromatography, as silica gel and alumina used as support and mm, inert than paper, and hence this is very much inert. But in cellulose paper there is water molecules are bound to the cellulose paper. That's why TLC is very much easier and a convenient process than your paper chromatography. It is a strongly reactive reagent, can be used to locate the compound. It is an universal technique, involve the use of iodine vapor. If the spots are not seen in ultraviolet or fluorescent lamp, then iodine vapor atmosphere is also used for spotting of the components. Then for colorless and non-fluorescent spot, it consists of exposing the developed plate to iodine vapor which interact with the sample component. So these are the reagents and these are the applications. The ninhydrin, this is for your amino acids. 2,4-dinitrophenyl hydrogen, 2,4-NPH, ketone aldehyde, hydrogen sulfide water for metals, rubianic acid for metals, aniline for your uh, aniline phthalate for your sugars, then followed by chloroplatinic acid for alkaloids, bromothiamol blue for lipids, antimony trichloride for steroids, essential oils. Okay. So then the RF value, what are the factors affecting the RF value in TLC? So RF value is an important parameter for for prediction or determination of the components. It depends on the nature of adsorbent, its chemical nature, particle size, surface area, and binder. Also, its activity, thickness, and uniformity. So so the adsorbent, that is the plate, TLC plate, that is stationary phase. So it depends on the nature of the adsorbent. Also depend upon the mobile phase, that is the purity, moisture content, precision of mixing in case of mixture, and volatility. So next will be the amount of sample used. Then is the vapor pressure equilibrium between the plate and the atmosphere of the developer chamber. Then last one will be the ambient temperature, is also one factor that affects the RF value. So this is just a figure for your thin layer chromatography of a mixture. Just see this. This is just a thin layer chromatography plate. Okay. So we put one origin here just above the bottom line. Then we put different samples. Okay. Then after immersed in the selected or selected solvent, there will be migration of the samples from origin. Then depending upon the distance covered, we will have our retention factor. There is a problem here. The problem is methanolic extract of medicinal herb, that is Terminalia arjuna. Back powder was passed through silica gel and with silica gel column and diluted by various solvents. This is 10:1 your solvent, petroleum ether and ethyl acetate. The TLC component ABC, the RF value was given. Then what happened? One of the component was carboxylic acid, which is identified as tartaric acid. In order to further confirm, a known standard tartaric acid was run on TLC, where solvent front up to 8.6 and spot was 6.3. That means the solute or the in stationary phase, it is 6.3 divided by 8.6, it will be 0.73. That is very much close to your tartaric acid RF value, that is 0.72, which is already given. This is 0.72. So that's why the spot B is your tartaric acid. Okay. So there are 3 samples taken and these are the RF values and the tartaric acid values are given here. Here this is the pure tartaric acid TLC 6.3 by 8.6. So this value is very much close to your spot B. And that's why spot B your tartaric acid. And the plate concept apply into TLC, and when we are determine the distance covered. Okay, so this distance covered is always measured with the your total distance covered by the solute divided by total distance covered by the solvent. So here the center up to the center the distance is measured and followed by the RF is calculated. And there is also one mathematical derivation here, that is the but time in mobile phase, that is the distance covered in solute phase, stationary phase divided by the linear velocity, because distance covered is velocity into time, so time is distance by velocity. Then followed by TR equal to dm by u, Then your last equation will be k dash, that is the distribution constant. This is dm minus ds by ds, and we have with respect to rf, it is k prime equal to 1 minus rf by rf, and we have this new equation. N is the number of plates and ds is the distance covered in stationary phase divided by w is the spot width. This is the spot width, this one, spot width. Okay, so this is w square, and the final equation will be plate height. H is distance traveled by the solvent, total distance traveled by the solvent divided by number of plates, that is n. And the last part, it is high performance TLC. Just we will see this slide. This is the RF value TLC technique. This is the TLC technique, and this is in hexane. This is the RF value calculation. This is the RF value. These are the applications. Okay. So let's move to our HPTLC. HPTLC means where the thickness of the TLC plate is 0.1 micrometer, and the particle size is less than 5 micrometer. Sorry, 0.1 millimeter, and particle size is less than 5 millimeter, 5 micrometer. So, in order to have a better resolution and sensitivity, TLC always coupled with different other spectrometers. Like as I already told you that mass spectrometer, FTIR, that is fluorescent transfer, infrared spectroscopy, these are also coupled with your TLC. TLC can be compared with liquid chromatography, and there is also another concept, that is reverse phase version of TLC has been proposed, where better separation can be obtained. Then quality of adsorbent in HPTLC. This is specifically purified silver silica gel of a diameter of 3 to 5 micrometer, and it may also be modified with chemically bonded layers with 5,000 theoretical plates, providing a much improved performance. Okay, so in uh, 3 centimeter length, we have 4,000 plates, and here in the quality of the adsorbent is 5,000 plates. The methodology of the sample application, the amount of sample applied in HPTLC is much smaller, typical volume being 100 to 200 nanoliter, with a compact diameter of 1 to 1.5 millimeter. Number of samples may be increased because of its compact size. Um, After developing the plate up to distance of 3 to 6 centimeter, compact separated spots are obtained. So this is almost 10 times much effective than your conventional plate, conventional TLC. So application of the sample on the plate is critical process in HPTLC. A convenient spotting device was used as platinum iridium capillary. This is very much costly. Platinum iridium capillary. This is a spotting device, but in conventional it is capillary tube or micropipette. But in HPTLC we have platinum iridium capillary, whose tip is polished to provide a smooth planar surface area of 0.05 millimeter square. That means for HPTLC, the capillary used is the platinum iridium capillary, whose tip or whose mouth is so polished that it will provide smooth and planar surface of 0.05 millimeter square. This so small. It is used with a mechanical applicator with which minimize damage to the plate surface. Quantitative analysis requires scraping of spot followed by dissolution or direct scanning. In order to shorten the procedure, solid phase extraction column is used to concentrate the sample, followed by automatic sampling device, so that multiple samples may be processed in a short time period and highly reproducible results are obtained. So this is a very much a precise method of separation, and this is a high performance. The high performance is related to all parts or all the component of the system. So high performance is related to your stationary phase having having less than 5 micrometer particle size, and the width of this paper plate is 0.1 millimeter. It is very small. And also the capillary used is the platinum iridium capillary, which is so the tip is so polished that it will have a planar and smooth. It will give planar and smooth surface of area 0.05 millimeter square. So everything is very much precise. So that's why it is it has high performance. Then how we can detect the in HPTLC? So in situ quantitative analysis carried out by direct photometric measurement. The photometric measurement means it is UV visible or iodine vapor measurement. For this purpose, single or double beam spectrometer are available. Scanning densitometer based on reflectance and absorbance of light are often used to measure the individual spots. The chromatogram is scanned with a moving beam of light, and intensity of reflected light from the plate surface is measured. So just see, this is the instrument, that is HPTLC. HPTLC chromatography. Just see, this is the HPTLC. So this is a HPTLC. Your high performance thin layer chromatography, where the plate size, particle size, size of the stationary phase, and the selected solvent as well as the detection techniques are so precise that it has high performance. So that this is the SPTLC machine. Okay, and these are the different components. We have your applicator, developer, visualizer. This is for your spotting. Then scanner, MS interface, that is mass spectroscopy interface also attached coupled with this. Then your derivatizer. So these are the different components we have in your HPTLC. Then HPTLC was developed by one company, that is CAMAG, CAMAG of Switzerland. Is developed HPTLC Vario system with key features of development with 6 different solvents side by side. This is so advanced that 6 solvents are placed or can be applied or can be used one by one. Sandwich as well as tank configuration making directly comparable result, and 6 different conditions of equilibration including relative humidity. So 6 different conditions are also applied to this CAMAC Switzerland developed HPTLC Vario system. And what are the applications of HPTLC or TLC? Just we will have our slide first. What are the applications? Now, TLC is used in qualitative and quantitative analysis to separate organic compounds and to rest the purity of compounds. This technique is useful for separation of lipid, amino acid, and sugars. It is useful in identification of component of a mixture, following the course of reaction, analyzing reaction collected during purification, analyzing the purity of the compound. And in our PDF, the applications at TLC is widely used for qualitative and also for quantitative purposes. Inorganic separation of metal alloys, soil, geological samples also carried out. It is ideally suited for following the course of the complex reaction. This is very much important that we will analyze or determine at the mid of the reaction that whether our product is formed or not, whether the reaction is completed or not by a timely TLC experiment by putting the reactant, product, and the reaction mixture. from time to time. After 1 hour, after 2 hour, after 5 hours, we may just take a few samples from the reaction mixture and compare this reaction sample with the reactant and the reaction mixture, whether the whole the reactant is consumed or not. If it is not consumed, that means the reaction is in progress, that is not completed. If the in TLC, if no reactant sample is there in the reaction mixture, that means the reactants are completely reacted. Like this is the course of the complex reaction. Then quality control, purity check, plant extract, biochemical preparation, clinical diagnosis, forensic test. All these applications are the TLCs frequently used. It is primarily used for the qualitative identification by comparison of RF, that we have already 2 to 3 examples. That is the lead pollutant in the air sample. That second one is your that was your nickel, manganese, zinc, like example. So depending upon the RF retardation or retention factor, we have the identification. Then we have the versatility of this technique has resulted in a rapid spread of its use in all the fields. Particularly sharp separations have been obtained by vitamins, fatty acids, lipids, etc. This is an example of your uh, trifola. Trifola, that is a mixture of Harida, Bahada, and Ola in Odia, but in English it is Harad, Bahada, and Amla. This is combiningly known as trifola. So we have to test the presence of gallic acid in trifola. So how to do this experiment? We have to make this sample with a suitable solvent, that is an ethyl acetate and methanol 7 into 3 is to 3 solvent system, and the standard gallic acid was spotted at 0.86 of retention factor. This is standard acid, and our sample also has, at the same distance, we have a spot that indicates the presence of gallic acid in trifola, that is at 0.86. Also, the presence of gallic acid is confirmed by your elemental analysis, IR, NMR, BCMS. All these things you have already learned from your MCH-03 paper, your from Dr. Mona Lisa Mahapatranagar. So these are the basic spectrophotometric techniques used for the detection of the unknown component in a sample. And TLC is just the cross-checking whether the particular component is present in our sample or not. Okay, so this is the identification of gallic acid in trifola using ethyl acetate methanol 7 is to 3 solvent system, where comparable RA values are observed. Then this is the two-dimensional TLC, where sample is spotted at one corner, just like this. In two-dimensional, I already told you that one horizontal and one vertical direction, two different solvents are used. Okay, so this is solvent A, the first solvent, where the sample is placed at one corner, and the TLC is run. Then we have the different components along this vertical line. Okay, so similarly, the same corner is now placed horizontally. That means what? Sorry, this is yes, horizontally. Then that is at 90 degree. Then what happened? The components are now separated in this direction. That means this is two-dimensional. One is in this direction, another in this direction. So we have two types of separation along two different axes with two different solvents also in here. And This is the final chromatogram
Hmm.
after the separation of horizontal and vertical direction. Quantitative aspects of
Galang
your
hai. But one
PC
postmortem
and
meri nahi.
TLC are the quantitative aspects of paper chromatography and the thin layer chromatography. And these
Hmm.
both techniques are used for identification of inorganic or organic components. However, both techniques can be used for quantitative analysis after taking proper care and suitable calibration. Uh, the following precautions must be taken. Standards and sample must be applied to the paper or plate in spot of similar size and similar concentration using micropipette. That if I put sample A 3 drops, that means sample B also put 3 drops, C also 3 drops after every rank. All solvents must be highly pure. While using mixture, those should be prepared carefully. Mixture means it is a percentage, that is 1 is to 3,
Relative, our
1% or
relative je.
2% or 7 into is to 3 ratio. So you have to prepare that mixture very carefully. So development chamber must be brought in equilibrium with same manner. So this is a development chamber or the chromatogram.
Acha na
Then
ke madhu.
after the development of the chromatogram,
Eh?
we have to spot the
Aitas no man aitas.
the spots. Then visual comparison of spot. The standard containing known amount and the sample must be run on the same sheet or plate, and their relative intensity or area may be compared visually. That means here in your garlic acid, what happens? The standard and the sample both are run on the same paper, and we will compare these two effectively. That's why this is a very much important point, that the standard as well as the sample must be run on the same paper. Okay. Then a physical measurement of color spots. This is physical measurement, that is reflectance or transmittance phenomenon using spectrophotometer, scanning photodensitometer, which measure plot intensity for organic fluorescent and substance. The fluorescent intensity must be measured under illumination with the ultraviolet radiation or your iodine atmosphere. Spot area measurement. The spot area determined by using the transparent graph paper, and counting the square within a spot is proportional to logarithm of the amount of the substance. These are the mathematical things we have to require for our RF calculation. Then radioactive measurement is here for your radioactive substances or samples using radio tracers or radiodable substances. Like we used C13, P17. So these are the radioisotopes. And then removal of the spots. The spots is cut from paper or removed from the plate by scraping of the adsorbent. The substance is eluted or extracted from the spot paper or adsorbent using dilute hydrochloric acid and slightly warming for inorganic substances and suitable organic solvent. The solution is made up to a standard volume, and then measurement are made by
Ini
spectrometry.
mana ke?
So Camas Switzerland pioneered is modern equipment of TLC, that is SPTLC. This is very much effective, having 32-bit window, software design. These are the advanced features in your SPTLC.
Khara kara sih.
Then this is just a pictorial comparison between TLC and PC. This is TLC and this is PC. And in TLC, what happened? There is a distinct separation between the spots of the components. That is RF difference is a minimum of 0.05 to zero point 0.1 RF difference. But here there will be there will be overlapping of the spots of two components in your paper chromatography. Okay, as this is paper, cellulose paper, and in this paper, water molecules are bound, so that's why this type of interfering will happen. But in TLC, as this is just a adsorbent phenomenon, and this is a silica gel platform, we're having some slurry with your calcium sulfate, that is plaster of Paris. And this technique is very much fast, inexpensive, and reliable, or very much effective than your paper chromatography. Just I read this one. A comparison of separation of nucleotides by TLC and PC under identical condition. Solvents is ammonium sulfate, 1 molar sodium acetate, isopropanol, that is 80 is to 18 is to 2. The first one is the TLC chromatogram using cellulose as adsorbent. Runtime is 90 minutes. And B is the paper chromatography using Sierra Stature and Skoll 2034 paper. Runtime is 135 minutes. So these are the distinct differences. That is how TLC is more effective than your paper chromatography. So these are the point of differences. In case of paper chromatography, cellulose paper acts as stationary support that is flexible, whereas TLC, that is adsorbent material coated on glass, metal, or plastic sheet, that is rigid, that is not flexible. Please see, in paper chromatography, the solvent rises by capillary action. TLC solvent moves similar to than in liquid column chromatography. Okay, so this is not capillary action, this is the phenomenon of adsorption. The development of chromatogram in PC may take of several hours, but TLC it takes only some hour, only half an hour or less. PC may be either ascending, descending, or circular, but TLC may be the horizontal or ascending state. Development standardization in TLC are somewhat different as the paper unit is hanged with a rod, whereas the plate member in latter case. So in TLC, in ascending time, it is just placed at the bottom, and in descending time, it is hanged from the top. So for quantitative aspect, the paper sheet must produce spots and need to be cut with scissors, whereas in TLC, the spots are small, right? In PC, what happens? This spot may be tear off, may be cut with scissors. In TLC, the spot is scratched, which is used to use the same TLC again. Soluble results of paper removed while the active TLC. This takes more time and is less reproducible, where TLC is much faster and more liquid. Reproducible means if we are able to trace the spot of this sheet, then we may run the same
Hello,
TLC
sir.
with same solvent, and the same spot will be there. So this is known as reproducible. Whereas in PC, paper chromatography, this reproducibility is not very much effective. If we wish to run the chromatography experiment second time, then this spot may not PC and TLC both have been carried out using postage machine plates, and reverse plate version has been plate concept has been adapted to TLC, and high HPTLC has been developed, whereas it is not used for PC. So the plate concept is for TLC as well as HPTLC, but this concept is not applicable for PC. The choice of paper is limited, whereas in TLC variety of stationary phase surfaces are available. So like your silica gel, alumina, other adsorbents are there, and surfaces like your glass, metal, your glass, metal, this is plastic are used for your PLC surface. Not many automated instruments have been developed in PC. Compared to PC, PLC, where automated samplers, capillary dispenser, development standard, and documentation system with camera software has been developed in your advanced high performance thin layer chromatography. So this is the characteristic differences between your paper chromatography and thin layer chromatography. Then this is all about your unit 6 that is related to your paper chromatography and thin layer chromatography. And we have the next unit. Just we will not discuss it today. That is next unit um, related to your gas chromatography. If anyone having any question, please put it in the chat box because I'm unable to listen you. My laptop has problem today. And Nazrul Haq, you want to say something? Mr. Nazrul, please mute your mic. Rajasmita Mr. Okay. So Nazrul, please put your question in the chat box or anything you want to share or anything you want to ask. Please put your question in the chat box. I am unable to listen you. Okay. So I am um, just sharing the next unit. Mr. Nazrul, please mute your mic. Sir, could you give your WhatsApp number so we can add in this group? Yes, yes, definitely. Just I am sharing. Mahendra Sahu. I am sharing my number and you all may save it for your future correspondence and add this number to your WhatsApp group. Is there any question related to today's class, that is paper chromatography or thin layer chromatography? This is very much a vast topic, and these two are included in one unit. So you will have to read these things very carefully, and if you have a basic knowledge, that is a broad knowledge on this, you may write effectively in your theory examination. So do not try to remember these things. Okay, remember, never try to remember these things, but you have to understand these things in your future um, in your workplace or in your labs. You may have applications in your workplace. Sir, if we submit our assignment for this year and could not able to attend the December session exam, do you have to submit assignment again? No, no, no. Assignment submission is only one time. So assignment and examination both are two different things. Okay. So you may submit your assignment in your study center, and the December session exam you may or may not attend. Then you will attend the next that is the examination in the July session. Okay. Now, what are the recent development in HPTLC? Recent developments. So this is not in your PDF, and if you wish to have a look, then I just search it here for you only. Recent advantages and advancement in HPTL. So these are some research articles are here. A novel approach for the development of fast universal HPLC to be used in system. Just go through these things. You will because I am not an expert in this field. Okay, just um, just I read these PDF and PPTs, and also some refer some books, and I just take your class. Actually, my field of expertise was in coordination chemistry, and so these things you may get from the practical का registration कब होगा? Okay, related to your practical, you will receive receive email in your registered email ID. So you have to wait. You should have patience for that. There is no a schedule for your practical examination or practical classes. You will have a practical class before your examination, and probably I with another teacher from any other institution will take the practical classes, and the experiments we will have in our classes. From that only your practical experiment or practical examination will be held. Okay. Anything else? What are the questions? The questions are related to your paper chromatography as well as your PLC. That questions like what is the principal technique of paper chromatography, how the stationary phase, mobile phase, the detection is carried out in thin layer chromatography, just like this. You have to read overally. Will practical exam will be held online or in lab? In from the Corona period to the last practical which was held in RC Bhubaneswar, this was held online, and you have to submit the practical records to the regional center Bhubaneswar by post or by hand. You have to submit the practical record. So you have 4 papers in practical. So you have to maintain 4 practical records, and you have to submit it to the RC Bhubaneswar or regional office by post or by hand. And after your evaluation of the practical record, then the practical examination will be fixed or will be scheduled. Our center has not informed anything about practical session till now. When will we get it, sir? So where is your center, study center, Rohini? Trivandrum. Okay. So you may contact directly to your study center related to your practical papers. Okay. I think this year the practical classes will conducted by RC Bhubaneswar. I think so, but I am not confirmed. And do not worry about that. You will get respective emails when the actions are carried out. Okay. So do not bother about that, Rohini. Then we have another question, Nagesh. Sir, when I submit my assignment, for submission of your assignment, you have to regularly check the IGNO website. Okay, IGNO website, the regularly notices are put there related to your submission of assignment, practical examination, theory examination, registration, everything is there. So I think assignment is submitted for your December session. After October, I think you are able to submit your assignment. So before that, you should check the website of the IGNO. Anything else, students? Okay, so long question. Okay. Rajasmita Misra. Actually, sir, in June month, I applied both for theory and practical. But practical exams, there is no announcement for date. Only theory exam, term and exam I have given. Sir, could you please advise about this? So, Rajasmita, what is your admission session in PGDSC? June 2022. That means your practical examination will be held in June 2023 because PGDSC is a 1 year course. So that's why I think your practical examination will be held very soon, maybe in this month or in the month of September. And about your theory exam, and subsequently you will appear your theory exam accordingly. Somnath, sir, study center is in Delhi. Then where will the lab class or exam will be held? Actually, Somnath, as this theory class of PGDSC is conducted throughout the country, so I think this year your practical classes as well as your practical examination will, if it is held, if it is conducted online, then it will be conducted by ASE Bhubaneswar, maybe, but I'm not sure. But you will get a respective emails or any notification in your email or in IGNOU website. Sir, will there be any lab classes? So, practical classes means if it is online, then you will have online classes, and if it is offline, then it is depends on your study center. Yes, how they will arrange your practical class. So, I suggest you all do not worry about the practicals because it is the responsibility of the IGNO Center Delhi head office, and secondary the RC center, regional center of your or your respective regional centers, and the at tertiary level, it is the responsibility of your study center. There are three levels are there to conduct all your theory and practical classes. So you only need to do one thing. You should regularly check your email. That is there any mail from IGNOU related to your practical and theory examination. Okay. So do not miss anything or from IGNOU, as this is a distance course. So you have to be very much proactive. Okay. So I think the questions are over, or anything else, and also students, this chromatography, you also have experiment in your paper number 3 in practical. MCH-03 paper, you have this chromatography experiment. Like your TLC, the spots are there. There will be migration or movement of the components. Then on the basis of the spot, the distance covered, we will have to measure the, we have determined the retardation or retention factor and all these. Okay. Where we should submit our assignment online or study center. No, no, assignment is always hard copy. No online or soft copy. The hard copy will be submitted at the study center which you have put in your application, online application. Anil Kumar, always the hard copy of the assignment should be submitted. If you submit it soft copy, then your result may or may not publish. Okay. Okay. So just one thing I will show you about the tomorrow's class. What we will have in our tomorrow class. Just wait. In tomorrow's class, we have uh, today we finished unit 6. Then we have block 3, that is unit 7. It is related to gas chromatography. Okay. So this gas chromatography is also very much important because in gas chromatography, this is coupled with mass spectrometer, and it is sent to the moon mission, the Chandrayaan mission, to for the effective or precise determination of the things or environment related data precisely. So that's why this is very much an effective chromatography, which is followed by your HPLC, like HPTLC. We have HPLC, high performance liquid chromatography, in our unit 8, followed by in unit 9 we have ion exchange chromatography, then followed by size exclusion chromatography, where it depends on the size. Then the last unit will be the membrane separation and electrophoresis. Sorry, this is the membrane separation, unit 11. Yes, and the last one will be the electrophoresis. So we have only 3 days left. That is to the second, third, and fourth. Uh, oh, okay, one student is there, Ojas. He's written that the HETP concept is almost same to an observer that we use in chemical industry. Yes, yes, yes. So these things we will learn in our next classes. So I think the it is time to wind up this session. So thank you to all for your patience hearing, and it is so thank you from my side as well as from the RC Bhubaneswar platform, that you are constantly with us in this online forum, and hopefully this cooperation will continue. And thank you to all.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.